Welcome to lesson 9.3, Pyramids and Cones. So before we get into the lesson, just like 9.1 and 9.2, you'll see as we go through the notes, lesson is pretty heavy in vocabulary and terminology, not as much computational math. So again, I encourage you, after going through this notes video and highlighting and writing out your notes, please take a few minutes to go back through, read the section before the practice problems in your textbook to make sure you fully understand what I'm covering here. Then, as you go through the practice problems, hopefully these vocabulary terms start to make a little more sense as you see more examples. So to begin with, obviously we're looking at pyramids and cones, and you want to understand that pyramids and cones are special types of conic surfaces. So in our last lesson, we were looking at prisms and cylinders being special types of cylindrical surfaces. Now we have pyramids and cones being special types of conic surfaces or conic. So the definition of a base: an apex, a conic solid, a pyramid, and a cone. So given a region in a plane, the base, and a point not on that plane, which in this case would be considered the apex. So we have a region, which is our base, and a single point not in that base region. That is what creates a conic solid. So the conic solid is the set of points between that base and the apex, and that includes the base and the apex. If we're just looking at the boundary, so not all the points on the inside, that's what we would call a conic or conic surface. So a pyramid is the surface of a conic or conic solid whose base is convex polygonal region. So if the base shape is any convex polygon, it's a pyramid. If its base shape is a circular region, it would be a cone. So the difference really is that base shape. If it's circular, it creates a cone. If it's any sort of convex polygon, it's a pyramid. And if it's just some sort of weird shaped base, an irregular base, then we just get a conic or conic solid. So then we'll start with pyramids. So the segments connecting the apex of a pyramid to the vertices of the base are the lateral edges. So if we look over here, XD would be a lateral edge, segment from the apex to a vertex of the base. So then we'd have XC, XE, XB, and XA. The other edges are called the base edges. So a base edge would be like AB, BC, CD, etc. Then the polygonal regions formed by the edges are the faces of the pyramid. So a face of this pyramid could be face XCD or face XBC. All the faces, other than our base, because the base isn't one of our faces, but all the other faces in a pyramid are triangular regions. These triangular regions are known as the lateral faces. So lateral faces are all of our triangular regions that make up our sides of the pyramid. Then pyramids, just like prisms, are classified by their bases. So if the base of a pyramid is, let's say, a rectangle, it would be a rectangular pyramid. If it's a hexagon, it would be a hexagonal pyramid. Then, if the base of the pyramid is rotation symmetric and the segment connecting the apex to the center of symmetry is perpendicular to that base, then the pyramid's a right pyramid. So if I took my apex X, connected it to the center of symmetry of base ABCDE, if it met that base at 90 degrees, it's a right pyramid. Any other angle, it's an oblique pyramid. And then lastly, we have a regular pyramid, which is a right pyramid whose base is a regular polygon. Then we move into cones. So for the cones, from its definition, a cone's like a pyramid in that it has one base and one apex. The difference is, again, the base of a cone is a circle. So we have an apex and a base, but that base has to be a circle. The line through the apex and the center of the circle is the axis of the cone. Other terms used for cones are like those used for pyramids. When the axis is perpendicular to the plane of the circle, it's considered a right cone. Any other angle, it's an oblique cone. So up here we can see a right cone. Our axis meets the circle at 90 degrees, or an oblique cone where the axis meets the base at any other angle. The only surface other than the base is known as the lateral surface of the cone. And a lateral edge of the cone is any segment whose endpoints are the apex and a point on the circle. So a lateral edge would be any point from the circle to the base, that segment connecting it, or from the base, I should say, to the apex. So then we get into the idea of heights. And when we move into our volume formulas, these will be very important. So the heights, also known as the altitude. So the altitude of a pyramid or a cone would be the line segment from the apex to the base that is perpendicular to the plane containing the base. So think of your height from the apex to the base, and it meets the base at 90 degrees in both a cone and a pyramid. So that height of the pyramid or cone would be considered the length of the altitude. So the length of that altitude is our height. Then each lateral face of a rectangular pyramid is an isosceles triangle, congruent to all the other lateral faces. The length of the altitude of any of these triangles, so if we look over here, it'd be L in the picture to the right. So that length L is called the slant height of the pyramid. A cone also has a slant height, which is simply the lateral edge. So either lateral edge of a cone is the slant height. Of a pyramid, it's the length of the altitude of any of those faces that are the isosceles triangles. So from the apex down here to that edge is going to create our altitude. So then we get into another hierarchy. This one's obviously looking at conic surfaces. So our most general term gets split to a cone or a pyramid. Then for a cone, we have a right cone or an oblique cone. For a pyramid, we have a right pyramid and an oblique pyramid. And more specific, if we have a right pyramid whose base is a regular polygon, then it's a regular pyramid. So now let's look at some different examples. So we know, shown to the right here, it's a regular square pyramid. So my base is a square. All sides are congruent. And then I can see in here it created the right triangle ABC. So we know this pyramid has a height AB of 10, and BC, that segment, is 7. Find the slant height AC. So we're simply going to use Pythagoras' theorem. So we know AB squared plus BC squared has to equal AC squared, because AC is the hypotenuse of that right triangle. So 10 squared plus 7 squared is x squared. So x squared is 149, meaning our length of AC, which is x, is the square root of 149, or approximately 12.2 units. Example 2 is asking us to use the sketch of the square pyramid to the right and identify some of our different vocabulary terms. So first, identify the base. The base would be our square, so EVIR. The apex would simply be T. Our lateral edges are any of the edges from the apex to the base. So we have 4 of them, which would be TR, TE, TV, and TI. Then how many lateral faces are there? Identify them. We have 4 lateral faces, which are 4 triangular faces. So it would be TEV, TER, TIR, and TVI. And then lastly, how many base edges are there? Identify them. So there's 4 edges to our base, which is a square. So it'd be edge RE, EV, VI, and IR. Then, doing the same thing related to a cone. So in example 3 tells us sketches of a right cone, with G being the center of our base. And DG is perpendicular to that. So identify the axis of the cone. So the axis is simply that segment from the apex to the base that's perpendicular. So it'd be GD or DG. Identify a lateral edge. Lateral edge would simply be segment FD or segment DE. Apex to any point on the circle. Our apex is point D. The height of the cone is the distance of the altitude, so it's not segment GD, it's just the distance, G to D or D to G. The slant height would be the distance FD or the distance DE. Then what does segment FE represent? FE simply is the diameter of our base, or the diameter of the circular base. And then segment GE would be the radius of the base. Moving on to example 4. Tells us to identify the types of figures shown. So remember, all pyramids are named based off of their base shape. So in this case, every shape is a triangle. So it would be a triangular pyramid. If we look at this one, our base down here is a pentagon, 5 sides, so it would be a pentagonal pyramid. In this one, here's our apex, so our base is over here, which is 6-sided or a hexagon, so it would be a hexagonal pyramid. And lastly, base shape's a circle, so it is simply a cone. And then we get to example 5. So it tells us the figure at the right is a regular pentagonal pyramid, with CA being 12 and AP being 4. So we know it's a regular pentagonal pyramid. Now CA meets that base shape at 90 degrees, forming the right triangle CAP. So our height is simply that altitude of AC or CA, so our height is 12. Find the slant height. The slant height would be the distance from point P to C. So that would also be the hypotenuse of that right triangle PAC. So PC squared would equal PA squared plus AC squared. So in other words, 4 squared plus 12 squared equals x squared. So x squared would equal 160, meaning that distance for PC, which is also x, is the square root of 160, which can be simplified to the square root of 16 times square root of 10, which is 4 square roots of 10, or approximately 12.65 units.